Circuits by Josie. Lesson 1. Electric current and static electricity. Electric current is the steady flow of electrons through like a wire or something. So there's the electrons, and they're going through that wire. That's how it works. Static electricity is like a one-time charge, like a little spark thing. Yeah. Second lesson, the atom. There are 3 particles in the atom. Protons, which are positive, neutrons, which are neutral, and electrons, which are negative. This is a picture of the particles in the atom. The protons and neutrons are on the inside, and all the electrons are on the outside. The electrons are lighter than any other particle. Mini lesson on electrons. Only electrons can flow through the current. This is because they are lighter and are farther away from the inside of the atom. Lesson 3. Particle directions and the basic rules of electricity. The particles in a circuit move from negative to positive. This is because electrons, which are negative, are a lot lighter than any other particle in the atom. Also, they're farther away from the center of the atom than any other particle, so they will move. The electrons move because opposites attract. So electrons are not attracted to electrons, but protons are not attracted to protons. Lesson 5. Voltage. The dictionary definition of voltage is an electromotive force or potential difference expressed in volts. It's basically the amount of volts in maybe a battery or a circuit or whatever. You need voltage because it produces energy in order to create a circuit. Usually when you're creating circuits, you use batteries, which is a form of voltage. A battery creates voltage in the circuit using energy. So it uses bam, that's energy right there. Lesson 5, resistance. Is this lesson 6? Resistance is something that is blocking or using up more energy in a circuit. So say we have all our electrons cruising through the circuit, and then bam! There's resistance here. And then it's obviously going to be like a smaller flow, just like 2 little wavy lines and a few dots. Well, this has like a bunch of wavy lines and dots. For example, here we have like a live circuit. There's there's the 2 wires, and here's like a clip, and here's like another clip, and there's like energy going through. This is a live circuit. And then we add a light bulb, best light bulb ever, which is a resistor, but this also creates heat and light. It takes the energy that the battery and circuit is producing and transforms it into heat and light that is used in a light bulb. Lesson 6 or 7, I don't remember. Ohm's Law. Ohm's Law was created by George Simon Ohm. This is what he looks like. Yeah. The basic rules of Ohm's law says that more voltage equals more current, and more resistance equals less current. In order to increase the strength of current flowing through a circuit, you can either add more voltage or decrease the distance. Yeah. Lesson 7, or maybe 8, series and parallel circuits. Yeah. So a series circuit is a circuit where current passes, I apologize. A parallel circuit is a circuit where a current can go through one of multiple branches. As you can see here, there's a wire here and a wire here connected to the battery. There's these two wires right here are powering this battery, but there's also a different wire connected here which powers this light bulb. I'm sorry, not battery, light bulb. And yeah. A series circuit is a circuit where current passes through all batteries and resistors. It's one pass. So say I have these two light bulbs on and they're glowing. If I were to remove the bulb from this light bulb, then this light bulb would go out as well because the current cannot pass through. The reason why you can still have current flowing through the reason why you can still have current flowing through a circuit if part of it is broken is because of parallel circuits. It's because there are multiple paths for the current to go to be delivered to any resistors, like light bulbs that need the power. So say I have set up a little circuit here, and there's like this wire is broken, so it's like dead at one end. But I still have another wire here that runs from here, and maybe it goes like back to there. And there's another bulb, then this bulb would still work, even though this wire is maybe dead or broken or whatever, because there's multiple paths for the current to flow through. If you add lights in a series circuit, so I have my battery and I have a wire and I have a single bulb, and then maybe I add 2 extra bulbs. With a series circuit, then every time you add a new bulb, each bulb will get dimmer. However, if you have a parallel circuit, the brightness will stay the same. So that was my little doodlecast, well, really long doodlecast, it's almost 8 minutes long, I'm sorry, on circuits. Yeah. Thank you, Josh. I hope I get a good grade. Woo.